accelerated convergence of free energy calculation with replica exchange through the temporary. So maybe you are curious where the 2 comes, why call the rest 2 instead of rest? Okay, later I will explain that. That's mostly come from implementation and computational performance issues. And this talk, my talk will be very, very computational. I won't, I will try to ignore those, very fundamental thermodynamic principle explanation. I believe Chris Chipot already give, lots of, comprehensive explanation and elucidation. So now I just focus on computation and very low-level application. So in reality, what kind of problem you should solve and how to use those scripts and even how many computing resources. So I will start from multiple copy framework or NAMD because all of you, I believe you are already very familiar with state-of-the-art NAMD simulation. So contemporarily, concurrently running multiple trajectories like free energy perturbation, umbrella sampling, string method, transition path sampling, all those popular methods involve a large number of concurrent NAMD trajectories, and those computational protocol involves massively parallel computing, and periodically, very often, those trajectories perform some communication. So in that case, NAMD developers specially designed a multiple copy framework. And later I will introduce what its specific aims and how it's implemented in NAMD, and introduce some popular applications like replica exchange, free energy perturbation, and some other sampling enhancement algorithm, and how they are built on the multiple copy framework. And as a very preliminary replica exchange method, I will introduce lambda exchange within free energy perturbation theory and show how lambda exchange minimizes hysteresis in free energy calculation and how it accelerates convergence. So the emphasis of this talk will be REST-2. I will introduce how REST-2 algorithm is designed and which thermodynamics rule it is based on and how it's implemented in NAMD, and a few street applications of REST-2. You will get a chance to see how REST-2 enhances the sampling of protein folding, unfolding transitions, and I will show you how to combine REST-2 with other free energy method. Here I will focus on free energy perturbation, as free energy perturbation calculation has a virtual reaction path. It's not in real geometry path. So free energy perturbation calculation basically is not that sensitive to the choice of reaction paths. But for umbrella sampling, just as Chris Chipot shows, you must be very carefully choose the reaction paths in geometry space like r, theta, phi, and all those Euler angles. But in free energy perturbation, you never suffer from those geometry things. And also, I will introduce a trick how apply REST-2 to enhance solvent assembly. Because in biophysical simulation, you very often you encounter some solvent inaccessible region or buried boundary pocket. In that case, perhaps you take maybe forever no solvent or very few water molecules enter this pocket. However, so we know that solvent plays a very important role in the sampling or thermodynamic properties of some protein structure, at least at the protein surface. A correct solvent sampling directly affects the protein's folding unfolding behavior. And finally, I will introduce how to combine REST-2 with umbrella sampling method to overcome hidden barrier of protein folding process. So multiple copy or multiple multiple trajectory algorithm, essentially is a kind of problem decomposition. Okay, once we see, given an MD simulation, once we see a problem of decomposition, the first thing occurred to us maybe just how to decompose this atom system into different spatial domains and then run parallel computing. But here, the problem of decomposition means we use multiple concurrent trajectory decompose a very large time scale problem. For example, molecular recognition from initial solvated state to final bonding state. This takes an extremely long time scale. In principle, it's not possible just to run a super long MD trajectories to achieve that. In that case, we decompose this large time scale problem into many concurrent, smaller time scale MD trajectories. We can see each trajectory as a bin or a window. Okay, this is the basic spirit of umbrella sampling. Okay, and those trajectories are weakly coupled and they are deployed based on some fundamental thermodynamic principle. And each trajectory is molecular dynamics trajectory with a biased term, like in FEP. Each trajectory has some specific energy term like van der Waals or electrostatic interaction is rescaled by thermodynamic coupling parameter. And periodically, inter-trajectory communication can be performed to obtain optimal sampling efficiency. Of course, those communication is not arbitrary. They must be filtered by some specific thermodynamic criteria. For example, Metropolis Monte Carlo, to decide which communication is acceptable and which communication should be rejected. So number of trajectories basically is controlled with acceptance ratio and replica travel speed, because all of these trajectories form a new extended thermodynamic ensemble. We would like each trajectory travels as quick as possible through the whole extended ensemble. With those multiple copy algorithms, we can get many quantitative information like net, bonding free energy, solvation free energy. We get the transition paths. Within the transition paths, we get the populations of all intermediate thermodynamic states. And we get a reaction rate and also get some population of protein folding, unfolding states. For example, from a computational aspect, all those intermediate MD trajectory can be run in a parallel way. And finally, they need for the high performance computing, especially massively parallel computing. So this is the scalable multiple copy framework in NAMD. They are a generic parallel partition mode. And Chipot will launch multiple NAMD instances concurrently. Each NAMD instance is a single trajectory run. It corresponds to an intermediate thermodynamic state. Okay. And Chipot will generate two communication fields. One just support a normal parallel run. Another set of communicators support replica exchange. Okay, and at the end user aspect, an end user can use communication-enabled TCL script to control those replica exchange pattern and frequency. Later, I will show some sample TCL script. Those TCL script is well templated in NAMD source tree. You can be, based on those TCL script template, you can write your own version, customized replica exchange. Okay, so these are some current existing MCI instances in NAMD, like REST2. Temperature replica exchange is already in NAMD source tree, including a whole complete work directory. accelerated molecular dynamics designed by element common groups and recently upgraded to Gaussian accelerated MD in combined with reflex exchange is also in MD now. And free energy perturbation in combination with lambda remedy and umbrella assembly remedy, these codes are already in MD source tree. And the string method, multi metadynamics, FFM,